Okay, looks like we got another one that I am not really sure how to do. Let's see, they want us to evaluate the integral of f. Okay. But they're also telling me that f is equal to g prime. So I'm going to take this integral symbol and I'm going to replace the f with g prime. So I got to take the integral of g prime from 3 to 5. Okay. So, well, what am I supposed to do? Well, I'll tell you what we're supposed to do. We're supposed to use one of the parts of the fundamental theorem of calculus. And the fundamental theorem of calculus says that if you ever taken an integral of a derivative, it's basically like they cancel each other out. However, it ain't that simple. You gotta still keep a 3 and a 5 if you start with a 3 and a 5. And then you plug it in, and you get g of 5 minus g of 3. And that means I gotta figure out what g of 5 minus a g of 3 is. And now you wanna know how to do it, right? Well, I'll tell you how to do it. They told you that g and h are inverses. And when they tell you h of 8 equals 5, if g is the inverse, then that means I know that I can switch the x and the y. So I could do that over here too. H of 3 equals 2. G of 3 equals 2. And now I got g of 5 is 8. G of 3 is 2. I plug them in here. And I'm done with the problem. Now, if that last part was a little difficult for you, maybe you want me to explain it. Think about it. H is equal to the inverse of g. So they were basically telling you that g inverse of 8 equals 5. Well, that's telling you in the g inverse world you've got 8 comma 5. But in the g world, you've got 5 comma 8. And you know what that looks like? It looks like g of 5 equals 8. And that's pretty much how I got g of 5 equals 8. But notice all I had to do was I had to put the x over here where the y is. And I put the y where the x is. You just switch them because they are inverses. Okay, so little bit challenging. Don't forget to subscribe, otherwise I quit YouTube.